Previously, we used t-test to compare two sample means when the samples were independent. In this case, a different version of t-test we're going to use. This version is used when the samples are dependent, which means the samples are considered to be dependent when the subjects are paired or matched in some way. So we are going to use the same sample for both groups. Let's take a look to our example. Here, for instance, the grocery chain manager wants to compare the sales without sampling and with sampling. His expectation is with sampling the sales will increase. So he selected 11 different stores. So you can see here those are different stores. 1 week sales without sampling and another week sales with sampling. So his expectation, the difference from N to O should be negative number. The reason because once you do not have sampling, then your sales is less than with sampling. So once you take the difference should be negative because the second column is higher than the first column. So our expectation H1 mu D, the mean difference for the data should be less than 0, negative number. So we are going to use a similar process for the hypothesis testing. So once we set up our hypothesis, the second step is to find out the critical value. In order to find the critical value, we're going to use again the t-test function t.inv.2t. The probability should be multiplied by 2 because it is one tail. If this was two tail, then we're going to use only B5, which is 0.05. Since this is since this is one tail test, we need to multiply level of significance by 2. This is how Excel works. For left tail or right tail, if we use t.inv2t, we need to multiply probability by 2. Degree of freedom, again, sample size -1, n -1, which is 10, which is here on the column B10. So once we know our critical value, -1.8125, any number less than this would be H1 accept, any number greater than this would be H0 accept, including -1.8125. Now, the next step is to find out our test value. And there's a formula, there's a different formula for the test value. Let me put this formula. This time, the formula a little different. So in order to find the test value, we need to take d bar already known. Here we take the average of the differences, minus 9.18, and we need standard deviation 8.93. So the mean difference is 0, sample size 11, d bar minus 9.18, degree of freedom B8 minus 1, sample size minus 1, standard deviation 8.93, and the standard error, standard deviation B11 divided by SQRT B8, which is sample size, and the t-test will be, so this is numerator and it will be denominator of this function of this formula. So B9 minus B4, d bar minus mu d, divided by B12, which is SD divided by square root of n. So the test value is minus 3.44095, which is on the left side of the critical value. So that tells me H1 should be accepted. With 95% confidence, we can conclude that sampling increases the sales.